Welcome to today's physical science lesson. My name is Mashudu Mamburu. Today we'll be revising chemistry. So that is our purpose for the day. You'll be writing a paper out of 150 marks, of which you are saying you'll still have your 20 marks for multiple choice, 130 marks for structured questions, the total of 150 marks. You will still be writing for 3 hours. Remember, we said you have 1.2 minutes for every mark. So don't forget that. You must time yourself so that you are able to write and finish the entire paper. Now, in terms of paper 2, your scope for our June exam is that we have metal materials, which is your organic molecules, which is half of the paper. So it's very much important. You must know almost everything in terms of organic molecules. You cannot leave anything because there will be many questions that will come from this topic. You are having chemical change as well, which is half of that particular paper. Remember, when you say chemical change here, we are referring to rates of reactions. We are referring to chemical equilibrium. We are referring to acids and bases. And this will include your stoichiometry as well as your energy change, which is what you have done in grade 11. You remember the potential energy diagrams and all that. So that will be part of this paper. And we are hoping that you will revise and make sure that you do well in paper 2. And this session will be discussing skills as to how do you go about answering questions, and then hoping that you will use those skills as you prepare for your second paper. Now, last year's paper, let's look at June 2024's chemistry exam, where the paper, as I indicated, question 1 was multiple choice questions based on all the topics that I referred to: your organic molecules, your rates of reactions, your chemical equilibrium, your acids and bases, as well as your stoichiometric calculations. Now, if we check there, you will see that we have nomenclature, which is question 2, naming of organic molecules. In that, we had the empirical formula as well. So it's important that we deal with the issue of empirical formula so that you know how to determine the empirical formula. Nomenclature was 22 marks. We had physical properties. Remember, in organic chemistry, we're doing 3 physical properties. That is your melting point, your boiling point, and your vapor pressure. So we'll talk about that as well, more especially on the skills of how to answer questions, because the main thing is if you can know how to answer questions, if you can have a skill of answering the questions, you'll be able to answer all the questions that you'll be asked. We'll be looking at the reactions of organic molecules, and then last year as well, there was integration, there was percentage purity there. So it's important that even today we look at percentage purity. We'll look at rates of reactions, which we had dilution there. You will remember C1V1 equals to C2V2, the dilution formula. Then you had to use it there. So it's important that you have that skill as well. In question 6, we had chemical equilibrium. And then here there was a Kc calculation with initial number of moles of product, meaning that it was not 0, the initial number of moles of the product. So it's important that you start to lean around that way so that you don't always think that at all times the product will be 0, because we can have equilibrium, and when equilibrium is disturbed, we'll have a new equilibrium. So the first equilibrium then being the initial. So it's important that it's not all the time that we will always have a 0 for the products when we are doing your rice table. So we'll refer to that as well. And then there was as well drawing of potential energy diagram. Potential energy diagrams for your endothermic, your exothermic, when the catalyst is added. So it's important that you go and you revise the potential energy diagrams with or without a catalyst. And we are saying acids and bases. We are doing the entire acids and bases here. We're including even pH. We're doing neutralization. We're doing hydrolysis. We're doing conjugate acid-base pairs. So there's nothing we're leaving out in terms of acids and bases. So you have to revise the entire topic. And then we won't be having redox reactions in terms of this paper. We'll be focusing on energy and change. So there will be that topic of redox reactions. Now, with no wasting of time, we'll start with our first topic, which is organic molecules. As I indicated, we have naming of organic molecules and isomers. which is under which was question 2. And then physical properties, as I indicated already, that under physical properties, we're looking at 3 of them, which is now your melting point, your vapor pressure, and your boiling point. And then organic reactions, we'll be looking at our reactions. You'll remember in terms of reactions here, we are focusing on addition reactions, we are focusing on elimination reactions, we are focusing on substitution reactions, as well as combustion or oxidation reactions. That is when your organic molecules, in this case alkanes, will be reacting with excess oxygen to form carbon dioxide and water. We will as well look at esterification, which is when a carboxylic acid reacts with a primary alcohol for our syllabus, and then we're able to form an ester and water with the presence of a catalyst, sulfuric acid. So it's important that you know all this and you are able to answer any other question that will be asked under organic molecules. As I indicated, that there will be a lot of marks that comes from here. So it's important that you spend time with organic molecules and you revise and you are ready and you go and collect as many marks as you can. Now, in terms of definitions, we are always saying our definitions you must define according to the exam guideline. So we're saying always follow exam guideline when you're writing your definitions. So we're still emphasizing you can't go to write exam without knowing what a homologous series is. Here we're saying these are series of organic molecules that can be described by the same general formula. They can be described by the same general formula. Those are homologous series. Remember, we're doing 9 homologous series, which is your alkanes, your alkenes, and your alkynes, your haloalkanes, your aldehydes, your ketones, your esters, your alcohol, and your carboxylic acids. So you have to know that these, within a homologous series, all of them will have the same, will be described by the same general formula, and then each member will differ from the other by CH2 group. So it's very much important to understand that if I'm talking about alkanes, they have the same general formula, which is your CnH2n plus 2. If I'm talking about alkenes, we'll say CnH2n. Alkynes, we'll say CnH2n minus 2. So you got to know all those 9 general formula for all those 9 homologous series. And then we are saying these homologous series, how do you differentiate between them? We are saying you differentiate between them using a functional group. Now, a functional group, we said, is a bond, is an atom, is a group of atoms. Don't forget, it's a bond, it's an atom, it's a group of atoms that determines the physical and chemical properties of an organic molecules. So the physical properties, which is in your question 3, are determined by these bonds, by these atoms, by this group of atoms that we refer to as functional groups. So functional groups are very much important because how the melting point, the boiling point, and the vapor pressure, our physical properties, depends on this functional group. You will have seen when you are doing your studies to see that if, for example, you are having OH as your hydroxyl group, as your alcohol, if you are having your alcohol there, you know that you will have a hydrogen bond, hence you will have a higher strength of intermolecular force. So it's very much important to understand the importance of this functional group. Even during reactions, the reactions and how these homologous series or how these organic molecules react depends as well on the functional group. Hence we are saying functional group are a bond, an atom, a group of atoms that determines the physical and chemical properties of an organic molecule. Now, you know the definition of hydrocarbons from its name already. You see these are organic molecules that are made up of hydrogens and carbons only. We always emphasize the importance of only there to say you can't define a hydrocarbon without emphasizing that it is made up of hydrogens and carbons only. So these hydrocarbons, we're saying they can be saturated or unsaturated. Remember, we are saying they have no multiple bonds between carbon atoms. Our saturated organic molecules have no multiple bonds between carbon atoms, whereas our unsaturated hydrocarbons, they have multiple bonds between carbon atoms. So it's very much important that you have that understanding and you are able to define all of this. And then we are saying we have structural isomers. Structural isomers, in terms of the isomers, you will have seen iso means same. What is same? Same molecular formula. So what are we saying? We're saying structural isomers have the same molecular formula but different structural formula. So we have three types of these structural formulas, which are structural isomers, which is now your chain isomer, your functional isomer, and your positional isomer. And we are saying as you define all of these isomers, you will always start by saying same molecular formula. That's where you will start. You will always say same molecular formula, but then you look at the name itself, say what is different in that structure. For example, chain isomers, you will say these are organic molecules with the same molecular formula, but different types of chain or different chain length. And then examples there is when you're having your straight chain and your branches. Definitely, they will have different types of chains. Positional isomer, not position, but positional isomers, we're saying they have the same molecular formula, but different position. What is in a different position? It is the side chain, it is the substituent, and the functional group. I always say SSF, so that you always remember that in a positional isomers, we're talking about three things that can be in different position. So it's the same molecular formula, but different position of the side chain, of the substituent, or the functional group. So the functional group can be moving. For example, you can be having an alcohol where you are having now, if I'm to give you an example, where you are having the OH in carbon number 1, and then that will be, if it's 4 carbons like that, that will be butan 1-ol. But we can move the OH to carbon number 2, then it becomes butan 2-ol. So butan 1-ol and butan 2-ol, they are positional isomers. Why? Because they have the same molecular formula but different position of the functional group. So we're saying always remember what is different. It is the side chain, it is the substituent, or the functional group. So very much important there for you to remember. Remember chlorine, we're treating it as a substituent when we're doing our naming. So if you are having 1 chloropentane and 2 chloropentane and 3 chloropentane, you can see that our substituent, which is our chloro, is in carbon number 1, carbon number 2, carbon number 3. So we'll refer to that as a positional isomer because they have the same molecular formula but different position of the substituent. So it's important that you have that understanding about these isomers. The last isomers that we do is the functional isomers. So functional isomers, same, they're isomers, they must be same molecular formula but different functional group. So what is different is the functional group. And we said these are functional isomers. We said we have 4 functional isomers that we know. That is your cake, and your cake, you are saying always remember, we are saying a carboxylic acid and esters are good examples of functional isomers. And we are saying aldehydes and ketones are functional isomers. So always know that in terms of functional isomers, we're talking about here your cake, we're talking about here your carboxylic acid and esters, and then your aldehyde and ketones as your functional isomer. So I think now you remember all these and you will ensure that in terms of these definitions, in terms of this concept that we discuss on this page, you are able to always remember and be able to write and collect the marks that you're supposed to collect. Now, with no any wasting of time, we want to spend more time with problem solving so that we share with you the skill of how do you solve problems. So let's look at this question, for example, number 1, which says, which one of the following is the general formula? Which one of the following is the general formula? The keywords there is general formula of alkanes. Those are the keywords. So we want general formula of alkanes. And then you will have checked, you know that CnH2n, will be general formula for alkenes. CnH2n minus 2 will be general formula for alkynes. At least with this, I'm revising with you the general formulas of these homologous series so that you are able now to always remember the general formula because they are important as well. CnH2n plus 2, where we have maximum number of hydrogens. Definitely, this will be the general formula of alkanes. So remember, alkanes is CnH2n plus 2. However, when you move to alkenes, you're going to remove the two hydrogens, hence it becomes CnH2n for alkenes. When you move from alkenes to alkynes, you remove another two hydrogens, you're going to get CnH2n minus 2. And then when it comes to alcohols, you're just going to replace one on the CnH2n plus 2. You only replace one hydrogen with the OH there. That's why now it becomes CnH2n plus 1 OH. Definitely, that must be the general formula of alcohols. So you are able now to determine the general formulas for these homologous series. I hope that helps you, and you will not forget the importance of knowing the 9 a general formula for the 9 homologous series that we talked about, which we said is AAA, Higg, A, and C, so that you don't forget that you have 9 homologous series, and we are saying for all of them, you must know their general formulas. I've shown you good examples there with those 4, and I know that you will look at all of them, and when you go to the exam room, you must be knowing all the general formulas for all the 9 homologous series. Now, let's go to question 2 there. Question 2 is saying, consider the following statement regarding the compounds in the same homologous series. It's very much important to always highlight the keyword, the same homologous series. So we're talking about organic compounds that are in the same homologous series. So we're saying organic compounds that are in the same homologous series, they have the same boiling point. Let's take one homologous series like alkanes, for example. You will have methane, ethane, propane, butane, pentane. Will they all have the same boiling point? No. As the chain length increases, the boiling point increases as well. So you will definitely know that the first option is not the correct answer. Now let's look at option Roman figure 2 there. It says compounds, always read from the statement, compounds in the same homologous series, they have the same functional group. How did we define homologous series? Because homo means same. We know that homo means same, but we said they have the same general formula. And if they have the same general formula within a homologous series belonging to the same family, they must have the same functional group. Definitely, Roman figure, this number 2 is correct. Let's look at Roman figure 3 there. They are saying compounds in the same homologous series, they have the same molecular formula. No, I've shown you with methane, ethane, propane. When you look at that, they don't have the same molecular formula, but they belong to the same homologous series. So the only option that is correct there is Roman figure 2. Then definitely our answer must be A. You see, when you're answering even multiple choice questions, which you are using here for consolidation, you are able to answer with confidence and knowing that you are answering correctly. Now, question 3 is saying name of the functional group. I'm happy with this slide as well to say you got to know that there are 4 functional groups that we must know them by name. We just don't describe them. We know them by name, and they are given here. And we are saying which one belongs here to the alcohol. So we'll look at all of them, then we'll decide which one is the alcohol. Let's look at the first option, which is option A, carboxyl group. Carboxyl group is a COOH, cool there. The cool there. Remember, when you are writing the structural formula of the functional group, you will show all the bonds around the carbon. So you see there, a carbon is surrounded by 4 bonds around it. That's what you will do. When you're writing that carboxyl group, you will write a C double bond O with an OH, but everything, oxygen must have 2 bonds around it, hydrogen must always have 1. So it's important that you show the correct number of bonds. So what have I done? This is the name of the functional group. This is the structural formula of the functional group. So whether a question comes and say, write down the structural formula of the functional group, you know how to draw it. And then what is the homologous series? What is the homologous series which this one belongs? We know this carboxyl group is for carboxylic acids. Carboxylic acids, they have carboxyl group as their name of their functional group, and the structural formula of the functional group for carboxylic acids is written like that. So you see, the question can come, any of those 3, you are able to answer with no problem. Now let's look, which means number A, alphabet A is not the answer to this question, because remember we're looking for the alcohol. Now let's go to B. For B, we're saying carbonyl group. Now let's check what is a carbonyl group. A carbonyl is a C double bond O. In this case, it must be surrounded by 2 carbons. So very much important that the C double bond O must be surrounded by 2 carbons. And each carbon, at all material times, each carbon must be surrounded by 4 bonds around it. And that's how you will write a carbonyl. And then we are saying this carbonyl, where do we find it? We find it in ketones. So important. They say, okay, they give you a ketone. They say, write down the structural formula of the functional group. That's how you'll write it. What is the name of the functional group for ketones? Is the carbonyl group. So you know how to draw it. You even know how to write, to name it, because these 4 functional groups have names. Now the formyl group is a C double bond O followed by hydrogen. Where do we get this one? We get it from aldehydes. So the functional group for aldehydes is the formyl group. The name of the functional group for aldehydes is the formyl group, and we are saying you will write it as C double bond O with an H, and always check the number of bonds. So the question can say, draw the structural formula of the functional group, or write the name of the functional group for aldehydes. Definitely you know how to go about it. And then lastly, we have a hydroxyl group. The hydroxyl group is a carbon. The functional group is the carbon that is bonded to the OH. The carbon. So don't make a mistake of writing a hydroxyl group as an OH, because if you say draw the structural formula of the functional group for alcohols and you write OH, you are wrong. It must be a carbon bonded to the OH, and always our number of bonds: hydrogen 1, carbon 2, and carbon 4, and oxygen 2. Make no mistake at all times that your oxygen will have 2 bonds, your hydrogen will have 1, your carbon will have 4. So we are moving like that, and then we are saying this is the hydroxyl group. We find it in alcohols. So we are able to answer the question to say the correct answer is D. Hydroxyl group is the name of the functional group of alcohols. I hope that helps you, and then you build your confidence and you are able to move. Now, which one of the following compound is an aldehyde? Remember the homologous series, they give us the suffix. They give us the suffix to say how will the name end. For aldehydes, the name must end with AL. So you are able to see that pentanal, this must be aldehyde, because it gives us the suffix how the name end. Pentan to all for alcohol. So you know that this one, all is for alcohols, al for aldehyde, and then pentan to own for ketones. So you see the suffix, we're getting it from the homologous series. ethyl propanoate. This one, the O8 esters, they have O8. Their name will end with O8. You know that is an ester. And then we'll talk about esterification, the process itself, because it's very much important as well for your exams. Now, which one of the following compounds is a carboxylic acid? Which one is a carboxylic acid? We have talked about it. By now you know. But the main issue here, we want you to understand the condensed structural formulas. Because if you are given a structure like that, you must be able to know which homologous series these organic molecules belong to. Let's look at number A. You have a C double bond O surrounded by 2 carbons. Definitely, you will know that this is a ketone. A ketone with 3 carbons. So definitely that must be propan. Propanone. That will be propanone. Remember, you don't have to indicate the position of the functional group of the C double bond O, because there is no positional isomers there. So you just call it propanone. Is fine. You don't have to say propan-2-one, because there is no any other propanone in this world. There's only one propanone. It doesn't have a positional isomer. So you will just refer to it as propanone. You don't have to say propan-2-one. Remember, when you are saying propan-2-one, is because you are different. When you indicate the number, you are differentiating it from another homologous series. Now, let's look at number B then. You can see we have a C double bond O and an H at the end. That one for aldehydes. So how many carbons? 1, 2, 3. You will know that this must be propanal. For aldehydes, propanal. So it's important that you understand all the formulas. Remember, we started with the general formula, the molecular formula, and then the structural formula and the condensed. This one is the condensed structural formula. So it's important that you are able to see that. And then the coup there, the C double bond OH. Remember, we only have 2 homologous series that have 2 oxygens, which is our ester and our carboxylic acid. And we know that for carboxylic acid, in carbon number 1, we have the C double bond O and the OH. So the 2 oxygens are in carbon number 1 in terms of carboxylic acid. So you are not confused. You know that when I see 2 oxygen, I will definitely know that is EC. It's either an ester or a carboxylic acid. When I see 2 oxygens within a molecule, I know that it's either an ester or a carboxylic acid. So definitely this is a carboxylic acid. And then for an ester, this 2 carbons, the carbon with the 2 oxygens must be surrounded by 2 carbons around it. So it's easy for you to differentiate between esters and carboxylic acid because of the position of the C double bond O. You know that the C double bond O for carboxylic acid is in carbon number 1, but for an ester, it must be surrounded by other carbons on either side, on the 2 sides. Now, this one is CH3, CH2, CH2, 3 carbons. You see, this is an alcohol with 3 carbons, so that is propan. Where is the alcohol? In carbon number 1, so you will call it propan 1-ol. Why do we call it propan 1-ol? Because if we take the OH to carbon number 2, it will become propan 2-ol. So as long as it is having a positional isomer, we are forced now to indicate the number where we will get our OH in the structure. Now, which one of the following pairs of compounds are functional isomers? Remember, with functional isomers, already I told you that functional isomers, we have cake. We said it's either a carboxylic acid and an ester, or an aldehyde or a ketone. So it's easy for you now to say, okay, do we have aldehydes and we have methanol and methanol? Definitely says no. We have a butane, alkane, and another. These 2, butane and 2-methyl propane. These must be chain isomers. They have different types of chains. You can see this one is unbranched, this one is branched. So this must be chain isomers. And then you have propan 1-ol and propan 2-ol. This must be positional because we are changing the position of the OH there. So this is positional isomers. And then you are having the carboxylic acid and an ester. Oh, from our cake there, you can see these two are functional isomers. So our answer is D. So with that skill, you are able as well to have confidence as you answer questions. Now, consider the following structure. Which one of the following pairs of reactants can be used to prepare this compound in the laboratory? Very important. Which ones can be used to prepare this compound in the lab? So you go to check now to say, okay, let's check how many carbons do we have this side of the oxygen. You can see that we have 1, 2, 3. And this part of the structure that doesn't have a C double bond O is from the alcohol. So you got to see that we had an alcohol with three carbons. And for this type of reactions, mostly we are using our primary alcohols. Definitely this must come from propanol. So you can see that this is from propanol. And on the acid side, the one that comes from the acid, the OH part, which is now O8, this part. And then you are able to see that, okay, this one is a carboxylic acid with 2 carbons. That must be ethanoic acid. And as I indicated, that we use primary alcohols. Definitely this must be propan-1-ol. Propan-1-ol. Remember, it's a primary alcohol. Why are we calling the primary alcohol? We're saying the OH or the hydroxyl group is in the carbon that is bonded to the OH is bonded to one other carbon. That's how we define our primary alcohols. We're saying the carbon that is bonded to the OH is bonded to one other carbon. So that's how we are saying this is primary. It is primary because the primary that was bonded to the OH is bonded to one other carbon. If the carbon that is bonded to the OH is bonded to 2 other carbons, we'll call that a secondary alcohol. And if the carbon that is bonded to the OH is bonded to 3 other carbons, we refer to it as a tertiary alcohol. So very much important. So in this case, we have seen we have propan-1-ol and ethanoic acid, which in this case we have ethanoic acid and propan-1-ol, which is option number C. So you are able to choose your answer. Remember here that during esterification, we are using our catalyst as sulfuric acid. And ester, this we call this propyl ethanoate. So these are 2 names. You don't have to make it 1 name. There must be space between the 2. So it's propyl from the alcohol and ethanoate from the carboxylic acid, ethanoic acid. So this is propyl ethanoate. So you will write the name like that. And this is not the only product that is formed during esterification. Remember, we're having an alcohol reacting with the carboxylic acid to form the ester plus water. So you must always have that in mind to say water as well is an inorganic product that is formed during esterification. So I hope that helps you as you are revising all these topics. Now, the issue of empirical formula, which is the simplest whole number ratio. Empirical formula refer to the simplest whole number ratio. And we are saying which one of the following is the empirical formula of 1,2 dichloroethane. Now, the best thing to do is to first draw the structure so that you can see ethane, and you can see in carbon number 1 we have a chloro, in carbon number 2 we have another chloro. Then you are able to draw it like that. From there, when you are having that structural formula, you can write the molecular formula, which in this case, it is C2H4Cl2. And remember, we're saying empirical formula is the simplest whole number ratio, which means we're saying, is there any other number that we can divide here so that we cannot be able to divide this anymore? And if you divide this by 2, you will get CH2Cl. Then that will be the empirical formula, which is the simplest whole number ratio that we get. In this case, it's CH2Cl, and you can see that in number B. So you're able to see the empirical formula. So I think by now you know the difference. This C2H4Cl2 will be the molecular formula. CH2Cl will be the empirical formula, which is the simplest whole number ratio. Now we move. IUPAC naming, very, very, very important that you have the knowledge of naming organic molecules. This skill you must have at all times. And as discussed, we are saying always we have the prefix. Prefix is from the substituents. Remember the substituents in terms of our syllabus. We are talking about your methyl, which is your CH3. We're talking about your ethyl, which is your CH2, CH3. We're talking about your chloro. We're talking about your bromo. And then iodoate. Sometimes they do ask about it, and your fluoro. So we can't leave them out because we don't know what the paper will have. So you have to know that these are the substituents, which means they belong to the same family called substituents, and there is no preference amongst them. When we are doing naming, we don't prefer any of them because they belong to that one basket called substituents. So don't be confused when you are doing naming. They are all substituents. We'll just check which one comes that you are able to reach faster as you are numbering your structure, and then you prefer in that order. So you will see when we do naming, we are emphasizing that all these are our substituents. And a substituent must always indicate the position of the substituent. So if we have a substituent, you will say 2-chloro if chloro is in carbon number 2. You will say 2-bromo if bromo is in carbon number 2. You will say 2-methyl if methyl is in carbon number 2. You will say 3-ethyl if ethyl is in carbon number 3. So all of these are our substituents, and we're saying they don't go alone, the substituents, they all go with their position to say where do we find them. Where do we find the substituent, which is your ethyl, your methyl, your bromo, your chloro, your fluoro, and your iodo? I think that will help you. Now, we have the parent chain now. The parent chain, which is the root of the structure, we're saying the longest carbon chain. How many carbons do we have on the longest carbon chain? And we are always guided by this to say 1 carbon is mid, 2 carbons is, 3 carbons prop, 4 carbons put, 5 carbons pent, 6 carbons hex, 7 carbons hept, and 8 carbons is oct. So very much important that you always check the longest carbon chain. And learners, sometimes they make mistake. If a carbon chain is written like that, they will think that the carbons that are going downwards, they are not part of the longest chain. They are still part of the chain. It's just that this structure is bent. So please, if a structure is this, you must know that all these carbons, they are part of the longest carbon chain. There's no branch there. It's one carbon chain is just bent. If you want, you can write it straight like that so that you see it clearly. So please don't be confused by structures that goes like that. And if you can check there, we're having 1, 2, 3, 4, 5, 6. So you're able to see that this will be a hex. And because there is no any other functional group there except for the carbon-carbon single bonds and carbon-hydrogen bonds, which we use for alkanes, definitely you are going to refer to this one as a hexane. So if you are having a substituent, you will definitely look for the position of that substituent. What am I saying? I'm saying when you are naming, you will always start from here. You will say, what is the suffix? I find it very easy when you do like that to say, what is the functional group? What is the homologous functional group that we find in this structure? And we said it's carbon-carbon single bonds, carbon-hydrogen single bonds. We said, okay, this is an ane. So we know that this is an ane. And then how many carbons in the parent chain? 6. So that would be hex. Remember, for alkanes, we write only for esters and carboxylic acid where we write 2 names. But all the others is 1 name. No matter how long the name is, you will write it as 1. If we have a substituent, for example, I can remove this and put a chloro there. Then I will be able to call this 1, 2, 3. So I'll call this 3-chlorohexane. So always the name is starting with the prefix, which is your chloro, your bromo, your iodo, your fluoro, your methyl, your ethyl. As long as you're having those branches, as long as you are having chloro, bromo, you must always start with them. We refer to them as substituents, and you must always show their their position. I hope that helps you as you continue with naming of structure. We're given this structure to name to say, consider the following structure. Which one of the following is the IUPAC name of the compound? Now, if you look at this compound, very tricky. I told you that sometimes the structure is bent. So you must always be careful of that. Remember, where the functional group will always take precedence, will always get preference in terms of numbering of, say, which one is carbon number 1. The carbon number 1 is this one. Why? Because it is the functional group. What is the functional group? We said this one is the carboxyl group. The name of that functional group, you said, is the carboxyl group. Where do we find carboxyl group? In carboxylic acid. So we know we are deciding that we first look for the functional group, and then the functional group tells us about the homologous series to say this is a carboxyl group and this must be carboxylic acid. So we have our carboxylic acid there, and then you are able now to do the numbering of the longest carbon chain, which can be 1, 2, 3. You have an option to go to the left or to the right. Is the same, doesn't matter, because the chain is the same. It's only 1 carbon on the left and the right, but the structure doesn't end up there. The structure ends, you can end it and on the left or on the right, is still the same. I chose to go that route. So you're able to see that this is 1, 2, 3, 4. And you know that 4 is butan. 4 is butan. 4 carbons is butan. And then because it's a carboxylic acid, it's a butanoic acid. So you see the functional group is saying this is an oic acid. The parent is saying 4 carbons, hence we're having butan there. Do we have any substituents? Yes, let's go and check where do we find the substituents. In carbon number 2, we find 2 substituents in carbon number 2. 1, 2. In carbon number 3, there is another substituent. So our substituents are the same. So we can now just call them 2.2 because in carbon number 2, we have 2 of them. So it's 2, 2, 3. So you are able to see that this must be 2, 2, 3. How many are they? There are 3. So this must be tri. And you see, I'm writing a comma between the numbers, the like terms. Like when I have the same, I just write a comma. But now same numbers, 2, 2, 3. But when I have a number and an alphabet, unlike terms, for you to remember, I will use a hyphen there to say this is tri what? Methyl. We have 3 methyls there. So the name of this one will be 2, 2, 3 trimethyl butanoic acid. And then you just go and check the 2, 2. Don't make a mistake. It's 2, 2, 3. I think I've added 2, 2, 2, 3 trimethyl butanoic acid. Then you are able to write it there. Don't be confused. And then you are able to choose your correct answer with no problem. Now let's move. I think those activities help you. As I consolidate this one, this is most of the time you are getting our question 2 that looks like this one. To say now, when you get this one, what do you do? How do you go about doing it? 100% you will always, hence I wrote here F.H. Jemison, for you to always remember that you must first look for the functional group. To say what is the functional group there, you can see that there is no any other functional group. Then this will be is carbon-carbon single carbon-carbon single bonds, carbon-hydrogen single bonds. This must be an ane. This must be an ane, and then that is means now alkanes. And then you check in how many carbons do we have in the longest carbon chain. So we'll be having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, number from anywhere is still fine. So you're having 6. So you know that this must be hexane. This must be hexane. Do we have substituents? Yes. Which one now is the take preference? Look, in this one is competing to be carbon number 1, as well as this one as well, competing to be carbon number 1. So I cannot decide based on these 2 terminal carbons, the first carbons on the left and on the right. I can't decide which one is carbon number 1. I must go to the next one. Let's go to the next carbon. We have a substituent called bromo. We have another substituent called methyl. So you see, they are all my substituents. So I told you about the issue of preference to say they belong to the same family. We don't prefer between a methyl and a bromo. So I must continue with my journey. Maybe something will help me to make a decision, because I don't know who to favor. I don't know who to prefer between bromo and methyl. Let's go to the next carbon. What do we get? We get a methyl in carbon number 3 from this side. Carbon number 3 from this side, there is nothing. There is only hydrogens. So I'm going to prefer the left-hand side because it's the mostly substituted side. So when I say now, this is carbon number 1, number 2, number 3, number 4, number 5, number 6, you will understand me. I don't hate bromo, but I'm saying that on the left, I have many substituents. So always when I'm preferring, I will prefer where the mostly substituted side. So I will prefer the left. Hence, when I'm numbering, I will number like that. Now, when it comes to naming, remember we said this is hexane. Now I will check, okay? In carbon number 5, we have a bromo. In carbon number 2, let me write what we have. In carbon number 2 and number 3, we have dimethyl. Because there are 2, we say dimethyl. Don't forget, like terms is a comma, number, comma, and then when it's alphabetic number, hyphen. Don't forget that. We penalize you if you don't do that. So we're saying 2,3 dimethyl. In carbon number 5, we have a bromo, so it's 5 bromo. And then we have hexane as the longest carbon chain. So when you write the name now, very much important, you are going to use always for writing the name, not for numbering. For writing the name, always you will use alphabetical preference amongst your substituent. So in this case, I will give the name of the structure as 5-bromo, because B comes before M for methyl. So this is 5-bromo, 2,3-dimethyl. Don't forget the hyphens. Dimethyl hexane. Don't forget the hyphens between the number and alphabet and the comma between the number and the number. Then we name that structure well. So always have that in mind. And I'm saying for each one, know the general formula, molecular formula, structural formula, condensed structural formula, isomers, as well as the name, IUPAC naming, to say how do we name the structure. So when you are given a molecular formula like that, you will first draw it so that you can see what is happening. It's very difficult for you now to know whether that is an aldehyde or an alcohol. But immediately you start to draw that structure, you will be able to see that you have 3 carbons and then you have 8 hydrogens. So it's 1, 2, 3, 4, 5, 6, 7, and you are left with 1 oxygen and 1 hydrogen. So you are forced to say and then OH there. So you are able to see that, oh, this must be an alcohol. So if we don't draw it, you won't know. You might make a mistake of thinking that it's an aldehyde or something. So hence I'm saying, when you're given a molecular formula, draw structural formula. You want to see things clearly so that you can make decisions that are informed. For example, then you are given pentan 2-O, draw it. And then the 2-O is showing you the position of our functional group to say, okay, in carbon number 2, we have the C double bond O. So you will draw the 5 carbons, and then you will be able to show that in carbon number 2, we have C double bond O. And then don't leave your structure like that, because we always penalize you if you don't show all the hydrogens in the structure. So pentan 2-O. So you're able to do that. We can ask you what will be the functional functional isomer of pentan 2-O. So you will know that pentanal will be the functional isomer, because you see aldehydes and ketones, they are functional isomer. So all that, and I'm hoping that any question that we'll get out of this, you are able to do with all the foundation that we've laid. Now, if I don't waste time, I want to talk physical properties. Physical properties as indicated, to say under physical properties, we don't do much. We're talking melting point, we're talking here vapor pressure, we're talking here boiling point. I have my reasons why I'm arranging them like that, because we are having a melting point. We're saying melting point is not a point. This one, you got to get it. Remember, when you do acids and bases, you have equivalence point and you have end point, and all those we refer to them as points. But these ones, they are not points. They are melting point is a temperature. It's not a point. It's a temperature at which the solid phase and the liquid phase are at equilibrium. You'll write it in full. The temperature at which the solid phase and the liquid phase are at equilibrium. And then what is the vapor pressure? We're saying the vapor pressure is the pressure exerted by vapor. Pressure exerted, you see, I'm just switching them like that to say it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. Please don't forget to say in a closed system when you're defining vapor pressure, because if the system is not closed, we won't reach equilibrium. For the second equilibrium. For the first one, remember the water is solid, so it's isolated. There's nothing that is coming in or going out. Hence, we don't say in a closed system. So remember, we're saying melting point is the temperature at which the solid phase and the liquid phase are at equilibrium. And the vapor pressure, we're saying, is the pressure exerted by vapor at equilibrium with its liquid in a closed system. Now we have what we refer to as boiling point. Boiling point as well is not a point. It's a what? It's a temperature at which the vapor pressure is equals to the atmospheric pressure. Don't make a mistake of saying the atmospheric pressure is equals to the vapor pressure. No, it is the vapor pressure that increases until it is equals to the atmospheric pressure. Remember, atmospheric pressure above sea level here is 101.3 kilopascal, what you call 1 atm. So it is the temperature at which vapor pressure is equals to atmospheric pressure. And those are the three physical properties that we do. And we are simply saying now, these physical properties now, this is what we are measuring here. This is our dependent variable. So look at this question as a question on an investigation or an experiment where the dependent variable, it is your melting point, your vapor pressure, and your boiling point. And I'm saying here for you now that let's look at our independent variable. What is that which we can change in order for us to change the melting point, the vapor pressure, and the boiling point? Because these ones were saying they are dependent. So these ones are dependent variables. What are the independent variables? I want to come here and write our independent variables, or what do we change in the structures. According to our exam guideline, we change the intermolecular force by changing the functional group. So we have the intermolecular force, we have the functional group. So when you change the functional group, we're changing the intermolecular force in our case. And then, so it's the intermolecular force, the functional group, and then the chain length. So the chain length and the branches. So those are the three things that you can change, because if you change functional group, in our case for grade 12, you are changing the intermolecular force, and then you are having the chain length. You can change the chain length and change the branch, and if we change those three, we are able to answer all our questions. So it means when you get your question, you will always check your independent variable and your dependent variable. At least the dependent, already you know them, is melting point, vapor pressure, and boiling point. So you just check what are we measuring in this experiment. Then you know that is your dependent variable, what we are measuring. What are we changing? We are saying we change the intermolecular forces, we change the functional groups, we change the chain length and the branch. Those are the three things that we change within a structure. So have that as we go to this question, we won't have a problem. Now you will know that we always put our dependent variables this side and our independent variables, what we are changing. In this case, is the number of carbons, which means we are changing the chain length. The chain length is changing. So you can see that as the chain length increases, you can see what is happening to the boiling point. As the chain length increases, the boiling point as well is doing the changing. You will see as we do the questions. So you will get the question in a graph form, the way I gave you like that, or you will get your question in a table form like that. And then we are saying that always know. If you look here, check what is changing, because already you know your dependent variable is your vapor pressure, which is your physical property, which is a vapor pressure. That is what we are measuring. We are measuring vapor pressure. But what are we changing? Which is your independent variable. Always have that information to say, okay, in this one, If we check, we have 1, 2, 3, 4, 5 carbons, we have pentane, we have 2-methyl butane, we have 2,2 dimethyl propane. So you can see that we are changing the branches. 0 branch, 1 branch, 2 branches. So you can see that, okay, as we increase the number of branches, what is happening to the vapor pressure? So you can see that the vapor pressure increases with increase in the number of branches. When you increase the number of branches, the vapor pressure increases. What does that mean to us? It means that as we increase the number of branches, the strength of intermolecular force is decreasing. And as the strength of intermolecular force decreases, less energy will be required to overcome the intermolecular force. Therefore, they will have more vapor that is formed. So it means when the strength of intermolecular force is the weakest, that's when we have the highest vapor pressure. Highest vapor pressure, meaning that we have the lowest, the one with the lowest boiling point has the highest vapor pressure, which means in this case, this one has the highest vapor pressure, which means in terms of boiling point, this one will have the lowest boiling point. And this one will have the highest boiling point. So have that in your mind to say, this is the relationship in terms of boiling point, vapor pressure, and melting point. Now, how do I go about answering these questions? So we are saying when you're answering these questions, the first thing that will always look is the difference in structure. I already indicated that I'm expecting you to look for 3 things: to look for the chain length, to look for the branch, to look for the change in the functional group. Already I told you that when you change this functional group, we're changing the intermolecular forces. So you'll always check in the structure what is changing. Then you answer the question based on what is changing, your independent variable, because we are always looking at the relationship between the independent variable and the dependent. How is the change in the independent variable affecting the dependent variable? As the chain length increases, the boiling point increases. You see, always the boiling point is depending on the chain length. As we increase the chain length, the boiling point increase. As we decrease the chain length, the boiling point decrease. Same with melting point. However, when it comes to vapor pressure, we're saying as you increase the chain length, you are going to expect that the vapor pressure will decrease. So that is the only difference in terms of vapor pressure. So the first thing, you'll say what is changing or what is the difference in structure. Number 2, you'll state the effect of this factor on the intermolecular forces. So does the change in chain length increase or decrease the strength of intermolecular force? What is the effect of increasing the number of branches? As you have seen that as we increase the number of branches, the strength of intermolecular force decreases. That's what we're talking about. And then what is the energy required, energy needed to overcome intermolecular force? So definitely when the strength is increasing, you know that more energy will be required to overcome the intermolecular force. I want us to practice this in a question so that you are able to answer the question. Now, this one is saying, which one of the following compounds will have the lowest boiling point? Which one will have the lowest boiling point? Remember, lowest boiling point, we are saying lowest strength in terms of intermolecular force. So you can just group them to say, okay, you have the understanding, alkanes, they have London forces. Aldehydes, butanol, they have London forces and dipole. So you will always refer to the highest strength, the highest force that they have, which is dipole forces. And then butan-1-ol has one side of hydrogen bonding. So this one is a hydrogen bonding. And then methyl propane, like butane, it will have London force. But compared to butane, methyl propane will have a less strength of intermolecular force. Why lower strength of intermolecular force? Because it has a branch. It's branched. Immediately when you increase the branches, you are decreasing the strength of intermolecular force. So you are able to see it like that. So we are saying which one of the following compounds will have the lowest boiling point? Oh, this one, highest, because it has all the 3. It has London forces, it has dipole, and hydrogen bond. And hydrogen bond is the strongest of all of them. So butan-1-ol is not the lowest, it's the highest. It will have the highest, followed by by butanol with dipole, followed by London forces, and the lowest will be methyl propane because it has London force same as butane, but methyl propane has a branch. So as a branch, further when you increase the number of branches, you are further decreasing the strength of intermolecular force. So definitely T will have the lowest strength of intermolecular force.